to hear this music, and we've yet to hear it. So. All right, so here's the deal with radical equations. Now, before I tell you about radical equations, remember rational exponents. What does that mean? What's rational exponent mean? What's rational mean? It could be a radical, but what's rational mean? What type of number is a rational number? It starts with an F. A fraction. Yes, a fraction. So a rational number is a fraction. So if I've got a fraction exponent, remember this is I can rewrite it as a radical, right? So remember rational exponents are, that's where I do the sunshine. Do you know how to change it? Like if I told you x to the 1/2, it's the second root of x, right? Or you don't have to put that 2 on there, because if you don't put anything, it's an implied 2, right? Okay. I'm trying real hard. I'm coming and going. All right, so let's run through some scenarios here, and then we'll do some practice. So scenario number 1 is I have this equation. Y'all know Roman numerals? We're just going to go through 2, so do you know 1 or 2 at least? All right, first scenario, 1 radical. If I just have 1 radical in my equation, what I'm going to do, or 1 rational exponent, I am going to isolate. What does isolate mean? Get it by itself. That's right. I'm going to isolate the radical or the rational exponent, whatever you have. Then I'm going to get rid of it, and I'm going to solve like normal. And I'm going to run through these. I just want you to have the steps here. What it is for them. Now, before I do this, I'm talking about eliminate. How do you eliminate a third root? What gets rid of a third root? Close. Okay, 2/3 roots will give you to the 2/3. Okay, give me an easier way to do it. Let me ask you this. Let me say it. If I had, you agree that that's the same thing. What exponent could I raise that to that would eliminate the 1/3 altogether? 3. Y'all agree, right? If I raise this to 3, I do a power to a power, and 1/3 times 3 is 1, right? And it cancels. So now come back to this third root. What would cancel out a third root? A third power. Those cancel each other out. Okay. Same thing, if I had a 4th root, what would cancel it out? A 4th power. What if I had x to the 2/3? What would cancel that out? That's exactly right. 3/2. That flips it. Okay. So I raise it, whatever the root is, I raise it to that power, or whatever the exponent is, I flip it and raise it. Does that make sense to everybody? I can digress and spend some time there if y'all need it. Or you want to just show you that these cancel out, things like that. So if I had, let me just show you. if I had the fourth root of x equals 2, and I needed to solve that for x, then in order to eliminate that radical, what would I do? Fourth power. The power here eliminates it, so I do the same thing on this side, and 2 to the fourth power is what? 16. So here x equals 16. Right? Pretty easy. Or if I had x to the, let's say 2/3 again, equals, let's say 8. Then in order to get rid of that exponent, what would I need to do? Keep going. 3/2, right? Does that make sense? And that cancels out. So this, and 8 does not have a perfect square. I could split it, but we won't get into all that right now. You could write it this way. You could write it this way. You could simplify it some. But right now, I just want us to focus on the solving because this is where we got bogged down. All right, so let's do some examples that have more than just this so I can show you what I'm talking about isolating. Let's say I have and I said solve for x. Tell me what I can do. What's your first step? That's right. Isolate the radical, right? Which means I need to subtract 10. You're right. So if I move the 10, I end up with x plus 7 equals 1, right? Now my radical is isolated. Do we see that? And so now that the radical is isolated, how do I eliminate it? You raise it to the power of 2. How did you choose the power of 2 instead of any other power? It's a square root, and the square root is a second root, right? That's the implied number here. So this is gone. And now I have x plus 7 equals 1. Now is this an equation you can solve? Yes. Once the radical or the exponent is gone, it becomes easy to solve. Subtract 7. Now, I do want to tell you about something funny that happens sometimes here. I'm not going to make y'all do this, but I want you to be familiar with the vocabulary of it, okay? Sometimes you'll get an answer, especially with square roots, and this happens because when you take a square root, you know how you get the plus or the minus? So one of them will work, and one of them sometimes won't work. Or sometimes when you go through and you solve this way, you'll get an answer that should you plug it back in, it won't be true. It won't give you, you know how you check your work whenever you first learn to solve equations? Sometimes you'll get an answer that you did everything completely right all the way down. And then when you go back and plug it in, it doesn't work. That's what we call an extraneous solution. That means it solved perfectly fine, but whenever I plugged it in, it didn't work. That's called extraneous. You'll see that on your homework and stuff. I'm not going to make you check for them because it doubles and triples your work. You have to plug everything back in, and I don't want you bogged down with that. Does everybody understand what I mean by extraneous, though? That's a vocabulary word that you may see on SAT or something like that. All right, let's keep going. Let's do another. You ready? What you doing first? Say again. You make it okay. So you're doing this. You didn't do that step. That's okay. You don't have to do that step, but if that helps you to see it, it's perfectly fine. What now? Absolutely. Remember, I want to get that radical or that exponential piece by itself. So in order to do that, I'm going to divide both sides by -9. And what is -36 divided by -9? Right? So now I've got 4 equals the square root of x minus 12. That's right. Square. Is that the equal? Yes? Is that right? Right. 4 squared is, and the squared and the square root cancels out. And I have x minus 12. Now is this something you can solve? What are you going to do? That's right. And what does x equal? I feel you. I'm struggling. All right. Yes, no, maybe so. One more? Yes, but it gets a little bit more difficult. So hang on. We got scenario 2 also. You want them to be x? You don't know what to do? Same process. I'm still going to do the same exact thing. Okay, I'm still looking to isolate my radical. So minus 7x. That's exactly right. If I move the 7x, I get square root 12 minus x equals x. Now I still have to eliminate the radical. How am I going to eliminate that radical? I got to square both sides. You do. And that's okay, because remember unit 1 we learned all about solving quadratics, right? How do I solve a quadratic like this? Well, square rooting it's going to get you back where you were the step before. Rewind back to unit 1. How do we solve quadratics? You got to make everything equal 0. That's always your first step in solving quadratics. Now, in deciding what to move where, I would always keep the squared term positive. It's going to make it easier on you. So instead of moving everything from the right to the left, let's move the left to the right. And we'll have 0 equals x squared plus x minus 12. Now what do I do? Got it, Jay. We factor. This is a factor problem, right? How do you know you can factor this when you look at it? That's right. That's right. Even half constant. And is there something that multiplies to negative 12x squared but adds to 1x? Negative 3 and 4. 4x and negative 3x. And I can even shortcut this one if I want to because my leading coefficient is. But I'll do it the long way for you. I always do my negative first. What can I take out of the first 2? X. What can I take out of the last 2? And so once I get it factored down, it looks like this, x minus 3x plus 4. But don't lose sight of what you're doing in this problem. The whole reason we did all this, remember, I'm trying to solve for x. This equals 0. So what does x equal? were to plug both of these in, you would find that one of them works and one of them doesn't. What do we call the one that doesn't work? You're close. Extraneous. Yes. All right. Y'all said to do a harder one. Y'all want one more like that? Let's do one more that does something like this. I'm going to let you try this one on your own. Where's that go? I what? What? Just stuck and staring others if you were writing. But let's go. Let's see what happens. If I go ahead and eliminate the radical, because the radical is isolated already, right? Say right, because that's right. So it's gone. So now I have 2x plus 3, but over here on this other side, I cannot distribute that squared, right? Say right. I have to FOIL it. So this is x plus 2, x plus 2. So FOILed out, this ends up being x squared plus 4x because it's 2x and 2x. Now I make it equal 0. So remember, I want that leading coefficient to stay positive. What you keep laughing about, Rat? You didn't get that? I'm not done yet. I'm not done yet. If I do minus 2, yeah, I would pull this side over to the right side. Is that what you're asking? I get 0 equals x squared plus 2x. That's 1. Now whenever I factor, what? Can I factor that? Yes. Did y'all recognize the pattern here? Did anybody pick it up? The perfect square trinomial? Square dances? Perfect square, multiplied and double give you what's in the middle, so it factors as, or if you factored it one way, x plus 1 squared, or x plus 1, x plus 1. So there is just one answer here, and it's -1. Is that what you got, Armando? You know what they say, close on account from horseshoes and us old people say that. Yeah. All right, what happened? What happens if I have more than one radical? So let's slide into scenario number 4. I'm trying to do extra examples because we struggled so much before, so I'm trying to go scenario 2. What do you say? Don't tell me. Salem, that's enough. Okay, more than one radical. More than one radical, we're going to get them on either side. We're going to separate them, so we're going to get them on either side of the equal sign, and then we're going to attempt to eliminate. And I say attempt to eliminate because depending on if it's just a radical equals a radical, we'll be able to get rid of them easy. But if it's a radical equals something plus a radical, it's going to be a FOIL situation, and it'll be kind of difficult. So we'll start out easy, and then we'll make it a little bit harder. All right, I'm using some different variables because these are. Huh? No, then we'll just solve. All right. So here they're already separated, right? You see that I've got more than one radical, they're already separated. So I'm going to attempt to eliminate. Now I gotta be careful because if you notice this one on this side, it's got this -2 in front of it. And that might cause me a little bit of trouble here in just a minute, but we'll see. All right, so somebody's gonna say something. How can I eliminate it? You've got to do the 3. That's exactly right. This time, because it's a third root, a 3 is what's going to eliminate it. So I'm attempting to eliminate my radical. Now, on the left side, easy peasy, right? Because it just cancels straight up. Okay. Now on the right side, yes, it eliminates this one, but because I'm multiplying here, I also have to take it to this 2. So what is -2 to the third power? -8, and then the cube root and the cube cancel. So I've got -8. Now that only worked like that because that number was in front of the radical. If that number was inside the radical, it wouldn't have done that, right? If this was -2n cube root like this, they would just cancel straight up. But here, because that 2's in front, and also be careful because I never ever do this without stopping to tell you. If it looked like this, that is different. I cannot distribute that here because it's adding inside. The only time you can distribute an exponent is when you're multiplying or dividing inside the parentheses. So, okay? I know, I've been talking too long, Caleb's chewing his fingers off. So, you would have to FOIL it out that many times. Not subtracting either, no plus or minus. Alright, can you solve this now? Alright, so what'd you do? You added the 8 in? That's okay. I'm gonna do whatever y'all say as long as there's multiple ways. Now what? Well, you divided your subtract 14, and now what? There you go, divide by negative. Do one more. Let's make it harder. This is about hard as it's gonna get. Ready? No, I'm talking about this one. Yeah, after the radical. Yeah, you got it. Say again. Just shut up. William, you don't have lunch today? Oh, no, where's that? I know. He always eats his full bagel sandwich. Fortnite takes it out of them. Who else tried? Can we go? Can we go? All right. I'm going to go ahead and square by sides to try to eliminate. Remember, this depends on what that root is as to what exponent I'm raising. All right. This one's gone. So I've just got x plus 9 on the side. But on the right side, what I end up with, I'm going to write this out twice because I'm in a FOIL situation here, okay? All right, here's where it gets sticky. Quick. Right, I'm just going to put you on the stool right here beside me. Square root of x plus square root of x, square root of x times square root of x is what? X minus the square root of x minus the square root of x plus 1. I'm kind of going slow through this because I want you to see what happens here. I've got x minus, what does this become in the middle? 2 square root of x, right? So minus 2 root x plus 1. Now, stop for just a minute because I attempted to eliminate the radical, but what happened? Didn't work. I still have a radical, but I only have one radical. Rewind back to your scenario with one radical. What do? Isolate the radical. So now that's what I'm going to do. So at this point, I'm back to scenario 1. And I'm going to isolate the radical that's there. Okay? So it could be that in your attempt to eliminate radicals, you still have a radical, but I can still solve it. I'm still going to go back and get it by itself. I would probably, if I was doing this one, I would probably subtract x and subtract 1. That way, I'm working, remember, to get this by itself. And conveniently enough, the x's just cancel here. So 9 minus 1 is 8. Have I isolated the radical yet? Close. I could do it now. Or I could go, I would probably go ahead and divide by -2. It'll just make my life a little bit easier. 8 divided by -2 is -4. Now can you eliminate that radical? Yes. How do you do that? That's right. What's negative? Tell me what you think about the radical equation. Is it, I was going to say compared to what we've been doing.